Welcome to the deep dive. Today, we're tackling a really big question, one that humanity's wrestled with forever, basically. How did everything, the cosmos, life itself, actually come to be?
Yeah, and the sources we're looking at today, they lay out this, well, really detailed argument for intelligent design. They position it as a serious alternative to explanations that rely only on purely materialistic processes.
Okay, so we've got this comprehensive case in front of us, and it's framing intelligent design not just, as a belief system, but as something you arrive at through looking at the science, through logic, when you think about origins.
That's the idea. So our mission here is to really dig into these arguments, understand what they're actually saying, their core points, and also critically look at the criticisms, especially from people like Richard Dawkins.
Right, and we also need to keep in mind the challenges that purely unguided natural explanations face when trying to account for everything.
It really taps into that deep human quest for origins, doesn't it? And this report suggests that maybe, just maybe, sticking strictly to a materialistic framework might, well, run into some roadblocks when explaining the sheer complexity and, dare I say, purposefulness we see.
So the central claim, the heart of it, is that some features, in the universe, in living things, they seem best explained by, well, an intelligent cause, not just random processes clicking away.
Exactly. And they stress this isn't like a purely philosophical or theological argument pulled out of thin air. They frame it as evidence-based, using empirical data, scientific observations, and logical inference, basically inference to the best explanation.
Okay, got it. So evidence-based. And this report, it's aiming to do three things, basically. First, build that positive case for ID. Second, tackle the big objections, Dawkins being a key one.
Right. And third, to kind of expose what they see as the weaknesses, the unanswered questions in those purely naturalistic, unguided origin stories.
It's a lot to cover, a really ambitious goal.
It is. And they kick things off by building that positive case, scientifically, logically, and a word that comes up again and again is information.
Information, okay.
Specifically complex specified information, or CSI. The argument is, whenever we see high levels of CSI in our everyday experience, think computer code, a book, hieroglyphics, it always traces back to an intelligent mind.
Right, like someone had to write the code, it doesn't just appear.
Precisely. And this brings us to their first major point, what they call the information enigma. And the focus here is squarely on DNA.
DNA. Yeah, this is where it gets really interesting. They bring in Stephen Meyer's work quite a bit here.
They do. Meyer argues, especially in his books, that the origin of the genetic information packed into DNA is just a massive hurdle for materialistic explanations of how life first started.
And it's not just that there's a lot of information, right? It's the type of information.
Exactly, it's specified. That sequence of A's, T's, C's, and G's, the nucleotide bases, it's not random noise. It functions like a digital code, like software, providing the instructions for building and operating life.
And they quote Henry Quasler, who apparently said way back that our experience consistently shows that creating new information, truly novel information, is always linked to intelligence, to conscious activity.
Yeah, it's a powerful point. They also highlight the arbitrary nature of the genetic code itself. How specific three-letter sequences, codons, map to specific amino acids.
Arbitrary? How so?
Well, there's no obvious chemical reason why that codon has to code for that amino acid. It seems to be a convention, like the symbols in a language. And that convention, they argue, suggests mental origin, a choice, rather than just chemical necessity.
Okay, that makes sense. Like deciding cat means a furry animal. And then comes William Dembski's big idea, specified complexity, CSI.
Right, Dembski's CSI is a really key concept for them. It's about identifying things that are both highly complex, meaning very improbable, unlikely to happen by chance, and specified, meaning they match an independent pattern or perform a clear function.
Can you give an example?
Sure. Think about spilling Scrabble tiles. You might get a long, random string of letters. That's complex, maybe, in the sense that getting that exact random string again is unlikely. But it's not specified, doesn't mean anything.
Okay.
But if those tiles spelled out, say, the first line of a Shakespearean sonnet, well, that would be incredibly improbable, and it matches an independent pattern. The rules of English, the structure of a sonnet, the meaning it conveys, that's CSI, complex and specified.
Gotcha. Complex but meaningless versus complex and meaningful.
Exactly. And Dembski argues that unguided processes, just chance operating under physical laws, are fundamentally incapable of generating high levels of CSI.
So how do they use this? They have this explanatory filter idea.
Yeah, it's a way to reason about causes. First, you ask, can this be explained by natural law, like gravity making an apple fall? If not, then you ask, can it be explained by pure chance, like the random string of Scrabble letters?
Okay.
If it's too complex and specified for law or chance to explain, like the sonnet, then they argue the best explanation left is design, an intelligent cause.
And they put a number on this improbability, right? Dempsey is universal probability bound.
They do. It's a staggeringly small number, something like 1 chance in 10 to the power of 150. It's hard to even wrap your head around how tiny that is, but
Right.
way smaller than the estimated number of atoms in the observable universe.
Wow. So incredibly unlikely.
Vanishingly unlikely. And the argument follows: the amount of complex specified information coded in DNA, often estimated at over 500 bits, which is way beyond that probability bound, strongly suggests an intelligent source. It didn't just happen by chance.
Okay, so that's the information argument. What's the next pillar?
The next big one is irreducible complexity. This was really popularized by Michael Behe.
Ah, yes, Darwin's black box. I remember that making waves.
It did. The core idea is pretty intuitive, actually. Some biological systems are like intricate machines made of many different parts, all interacting. And the key is, if you remove just one of those essential parts, the whole system grinds to a halt. It loses its function entirely.
Like the mousetrap analogy he uses.
Exactly like the mousetrap. Take away the spring or the hammer or the holding bar, it's useless. It's irreducibly complex because you need all the core parts there simultaneously for it to work at all.
And Behe points back to Darwin, doesn't he?
He does. Darwin himself said very clearly that if you could find a complex organ that couldn't possibly have been formed by numerous successive slight modifications, his whole theory would break down.
So ID proponents are saying, here they are. These irreducibly complex systems fit Darwin's own criterion for failure.
That's precisely the argument. They contend these systems can't be built gradually through Darwinian evolution because the earlier, simpler versions wouldn't work. They wouldn't provide any function for natural selection to favor.
What are some key examples they use?
The bacterial flagellum is probably the most famous one. It's this amazing whip-like tail some bacteria use to swim.
The outboard motor thing?
Yeah, it's remarkably like a tiny biological outboard motor. It has something like 40 or 50 distinct protein parts. A rotor, a stator, a drive shaft, bushings, a propeller. It's incredibly sophisticated.
And their argument is you can't build that piece by piece.
Right. What good is half a propeller? Or a drive shaft without a motor? They argue all the core components needed for motility have to be present and integrated for it to function. That coordinated complexity points to purpose, to design.
What else? The blood clotting cascade.
That's another classic example. It's this complex sequence of proteins activating each other in a precise order to form a clot and stop bleeding. Again, the argument is that the core components need to be there working together. Remove one critical factor, and the cascade fails.
So it's not just that we don't know the evolutionary steps yet.
That's a crucial distinction they make. It's not just an argument from ignorance, they say. It's an argument from the nature of the system itself. The functional interdependence, the purposeful arrangement of parts, is seen as a positive indicator, a hallmark of intelligent design.
Okay, so we have information in DNA, irreducible complexity in biological machines. What's next?
Next, they scale up, moving from the microscopic to the cosmic. They talk about the finely tuned universe.
Ah, the idea that the universe itself seems set up just right for life.
Exactly. The fundamental constants of physics, like the strength of gravity, the charge of an electron, the basic laws of nature, even the initial conditions of the Big Bang, they all appear to be balanced on a knife edge, dialed in with incredible precision to allow for a universe where stars, planets, chemistry, and ultimately life could even exist.
And this isn't just an ID talking point, right? Physicists acknowledge this.
Oh, absolutely. They quote prominent physicists like Stephen Hawking and Paul Davies who've written about this fine-tuning. It's widely recognized, though the interpretation differs, of course.
Give us some examples. How fine-tuned are we talking?
Well, take the cosmological constant. It relates to the expansion rate of the universe. Its value is apparently fine-tuned to something like 1 part in 10 to the power of 120.
1 part in 10 to the 120. That's incomprehensible.
It really is.
Oh.
If it were just fractionally larger, the universe would have blown apart too quickly for galaxies or stars to form. Fractionally smaller, and it might have collapsed back on itself almost immediately. No life either way.
Wow. Any others?
Plenty. The ratio of the electromagnetic force to gravity, it's about 10 to the 36. If it were slightly different, you'd either have stars that burn out too fast or stars that couldn't produce elements heavier than hydrogen. Again, no complex life.
It's like a whole control panel of dials, and they all have to be set just so.
That's the analogy. The strength of the strong nuclear force, which holds atomic nuclei together, the weak nuclear force, crucial for supernovae spreading heavy elements, the precise mass difference between protons and neutrons. The list goes on. All these fundamental parameters seem to fall within extremely narrow life-permitting ranges.
So the argument is, getting all of these right by sheer chance is just astronomically improbable.
That's the core of it. They argue this incredible precision, this purposeful arrangement of cosmic parameters, points strongly towards an intelligent designer who set up the universe with the intention of allowing life to exist.
And they mentioned Stephen Meyer making the point that whatever set these conditions must be outside the cosmos itself.
Right. Since these are the fundamental parameters of the universe, the cause responsible for setting them would likely need to be transcendent, existing beyond space and time, not just another being within the universe.
Okay, so cosmic fine-tuning is the third pillar, and they round out this positive case with philosophy.
Yeah, they connect these scientific arguments to long-standing philosophical lines of reasoning. They call it philosophical corroboration.
Like the argument from design.
Exactly, the teleological argument. This goes way back. Plato, Aristotle, Aquinas. William Paley's watchmaker analogy is the famous version. If you find a complex watch, you infer a watchmaker who designed it for a purpose.
So ID is like a modern scientific version of the watchmaker argument.
In a way, yes, but updated, focusing on specific, empirically detectable features like CSI and irreducible complexity as the markers of design, rather than just general order. It's about seeing that ordering to an end, as Aquinas or Paley might say, in nature.
What other philosophical arguments do they bring in?
They discuss the Kalam cosmological argument, which William Lane Craig has championed, and Meyer also discusses. It's a simple syllogism.
Okay, let's hear it.
Premise 1. Everything that begins to exist has a cause. Premise 2. The universe began to exist. Conclusion. Therefore, the universe has a cause.
Seems logical enough.
They defend premise 1 as intuitive, almost self-evident, and premise 2 is supported by modern cosmology. The Big Bang implies a finite beginning, and also by thermodynamics.
And what about the nature of that cause?
Well, if the universe had a cause, that cause must itself be uncaused. Timeless, since time began with the universe. Spaceless, immaterial, incredibly powerful, and, they argue, personal. Having volition, intelligence, to choose to create. These attributes align strikingly well with the traditional concept of God.
Interesting. And there's one more, consciousness.
Right, the argument from consciousness. How do we explain subjective experience? The redness of red, the feeling of pain, what philosophers call qualia. How do we explain reason itself? And the fact that the universe is understandable, intelligible to our minds.
Materialism struggles with that.
ID proponents argue it does. Purely physical processes don't seem adequate to explain the emergence of mind, reason, and subjective awareness. They mention C.S. Lewis's argument that if our thoughts are just the product of non-rational physical processes, why should we trust our reasoning, even our reasoning about naturalism?
So the fact that the universe has a rational structure and our minds can grasp it suggests a connection.
It suggests, they argue, a foundational intelligence underlying both. Maybe even hinting at an eternal mind, as Plato might have suggested, that grounds the eternal truths our minds can access.
So these philosophical arguments provide a kind of intellectual framework that resonates with the scientific evidence for design.
Exactly. They offer a coherent picture where the scientific data pointing to information, complexity, and fine-tuning fits naturally with philosophical arguments for a designing intelligence, a first cause, and the reality of mind. Things that are often difficult to reconcile within a purely materialistic worldview.
Okay, that's a pretty comprehensive overview of the positive case they're building. Information, irreducible complexity, fine-tuning, philosophical backup. Now, the report shifts gears, right, to address the critics.
Yes, and they focus significantly on Richard Dawkins, who is, arguably one of the most prominent and vocal critics of intelligent design.
And their take is that Dawkins maybe doesn't always get their arguments right.
That's often the feeling among ID proponents. They suggest his criticisms sometimes mischaracterize what ID actually claims, or perhaps underestimate the real difficulties faced by unguided processes, and maybe rely on his own philosophical assumptions that aren't always examined.
They even mentioned Dawkins calling theism an exciting scientific hypothesis at one point.
Yeah, they highlight that to suggest the disagreement isn't necessarily about whether design is in principle scientifically detectable, but more about how you interpret the evidence and what counts as a good explanation.
Okay, so what's the first major Dawkins objection they tackle?
Irreducible complexity. Dawkins basically argues it's an argument from ignorance. Just because we can't figure out the evolutionary pathway now doesn't mean one doesn't exist or wasn't possible.
He suggests evolution can do it through things like co-option, taking existing parts and using them for new functions.
Right. Co-option, gradualism, small steps building up over time. And he points out, fairly, that Darwin himself anticipated this kind of objection.
So how do ID proponents respond to that?
The rebuttal is essentially, show us the details. Vague scenarios aren't enough. The challenge, they say, is to provide specific, step-by-step, empirically plausible pathways where each intermediate stage is functional and provides a selective advantage. Waving hands about co-option doesn't cut it, especially when many proposed precursors are themselves already quite complex.
They use the bacterial flagellum again here, right? Against the T3SS argument.
Yes, that's a key case study. Dawkins and biologist Ken Miller have pointed to the type 3 secretory system, or T3SS, which is used by some bacteria to inject toxins. It shares about 10 protein parts with the flagellum's base. They suggest the flagellum could have evolved from something like the T3SS.
Makes sense on the surface, a simpler precursor.
But ID proponents like Behe, Dembski, Scott Minich, and Meyer push back hard. They point out the T3SS is only a small fraction of the flagellum's 40-50 parts. Crucially, it lacks all the key components for motility, the motor proteins, the filament, propeller. It does a completely different job.
So it's not really a functional intermediate towards motility.
That's their argument. It's like saying because a spark plug exists, it's easy to evolve an internal combustion engine. There's a huge leap in complexity and integrated function missing. They even cite research suggesting the T3SS might have actually devolved from the flagellum, losing parts, rather than being its ancestor. The evidence isn't clear-cut for the T3SS first idea.
And they mention experiments too.
Yeah, Scott Minich did genetic knockout studies. He systematically removed genes for individual flagellum parts and found that taking out almost any single core component resulted in loss of motility. This, they argue, supports the idea that the system is genuinely irreducible.
It's interesting they even quote Dawkins admiring the flagellum's design.
They do. Dawkins called it an astonishing piece of machinery, acknowledging the rotating axle as unique outside human technology. ID proponents see this as tacit recognition of its design-like nature.
Okay, what about the blood clotting cascade? How do they counter criticisms there?
Similar line of argument. Critics point to simpler clotting mechanisms in organisms like lampreys, or suggest gene duplication allowed the system to grow more complex over time. They also note that factor 12, one component, seems dispensable in some animals like whales.
Implying it's not truly irreducible.
That's the implication. But Behe and others respond that just finding simpler systems elsewhere, or showing some parts can be lost in some lineages, doesn't explain how the specific, complex, integrated vertebrate system was assembled step by step through unguided processes.
They question the intermediates again.
Yes. What was the function and selective advantage of, say, having just one or two factors of the cascade? Could an unregulated clotting factor actually be harmful? They argue the challenge remains to detail a plausible Darwinian pathway to the full system, where each intermediate step works and is beneficial. Dispensability in some specific cases doesn't negate the core system's interdependence in others.
All right. Moving on from irreducible complexity, what about Dawkins's criticisms of specified complexity, the CSI concept?
Dawkins argues that natural selection is the mechanism that creates apparent design, or disignoid objects, as he puts it. His famous Weasel computer program is meant to demonstrate this.
The one where random letters evolve towards a target phrase.
That's the one. He also raises the who designed the designer objection. If complex things need designers, then a complex God would need one too, leading to an infinite regress.
How does the ID camp respond to the Weasel program?
They argue it actually proves their point, ironically. The program only works because Dawkins, the intelligent programmer, sets the target phrase in advance and designs the selection mechanism to preserve changes that move closer to the target. It's guided, not unguided. It requires foresight and intelligent input.
Ah, so it smuggles in the intelligence it claims to replace.
That's the critique. They also point out that Dawkins himself uses CSI logic constantly. When he sees Mount Rushmore or a functioning watch, he immediately infers human design because of the specified complexity. He agrees CSI needs explaining.
So the disagreement is whether natural selection can generate high levels of CSI in biology.
Precisely. ID proponents say no. The probabilistic hurdles are too high. And there's no known natural mechanism that generates brand new functional specified information on that scale. Selection acts on what's already there. It doesn't invent fundamentally new blueprints.
And the who designed the designer point.
They generally see this as a philosophical diversion, a category error. When an archaeologist finds an arrowhead, they infer a human designer based on the object's CSI. They don't need to first explain the origin of the human designer to make that inference valid.
So detecting design is separate from identifying or explaining the designer's origins.
Exactly. That's a different question, possibly a metaphysical one. They also argue the objection wrongly assumes the designer must be complex in the same way its creations are. An ultimate cause, like the god of classical theism, could be argued to be metaphysically simple or necessary, not contingent and complex like the universe.
And they defend Dembski's math.
They do. They acknowledge criticisms, but argue his framework provides an objective way to measure CSI and make the design inference rigorous. The core claim remains: the odds of getting high CSI by unguided means are so low that design is the better explanation.
Okay, one more Dawkins critique. Biological information, especially the genetic code.
Right. Dawkins argues the near universality of the genetic code across almost all life is knockdown evidence for a single common ancestor. Shared genes between different species also fit this picture of a shared history.
Seems like strong evidence for common descent. How do ID proponents counter?
Interestingly, they argue this data fits just as well, maybe even better, with common design.
Common design, how?
Think of engineers. A good engineer reuses effective designs and standard components across different projects. Why reinvent the wheel? An intelligent designer creating various life forms might logically reuse an efficient information system like DNA and the genetic code.
So shared features don't automatically mean unguided common ancestry.
Not necessarily, they argue. It could mean a common blueprint, a common designer. They also point out the code isn't perfectly universal. There are minor variations. And its high degree of optimization against errors might itself suggest design.
They also bring up junk DNA, right?
Yes. The prediction from a purely Darwinian view was that genomes would be full of non-functional evolutionary leftovers. ID proponents predicted much of this junk would turn out to have functions, and increasingly, research like the ENCODE project is finding regulatory roles for non-coding DNA, which they see as support for their prediction.
What about conflicting evolutionary trees?
They mention that too. Sometimes trees based on anatomy conflict with trees based on different genes. This complicates a simple, single branching tree of life. They suggest a designer reusing functional modules in different combinations could explain these discrepancies better than strict common descent.
So ID isn't necessarily denying common descent entirely?
Not always. Some ID proponents accept common descent, but argue the mechanism driving it wasn't unguided natural selection alone. The core ID argument is against the power of unguided processes to generate the necessary information and complexity, regardless of the exact pattern of ancestry. Common design explains the shared code in genes just as coherently, they contend.
Okay, so they've presented their case and rebutted criticisms. Then the report turns to critique the standard naturalistic origin stories themselves.
Exactly. The third major section examines what they see as the impotence of spontaneous creation, looking at the problems facing theories like abiogenesis and cosmological models of a universe from nothing.
They argue these theories have fundamental flaws.
Yes, beyond just missing details. They point to massive improbabilities, a lack of demonstrated mechanisms, and sometimes even a subtle reliance on investigator intelligence in the experiments meant to support spontaneous origins.
First up, abiogenesis, the origin of life from non-life.
This remains a huge, unsolved problem for materialism, they argue. The gap between simple chemistry and even the simplest known living cell, with its complex information processing and machinery, seems vast and unbridgeable by unguided steps.
They critique the Miller-Urey experiment.
They do. While famous, it had issues. It assumed an early Earth atmosphere, methane, ammonia, that geochemical evidence now suggests wasn't accurate. A more realistic atmosphere yields far fewer useful organic molecules.
And it didn't make life, obviously.
Not even close. It made a few simple amino acids, and critically a mix of left and right-handed versions, while life uses almost exclusively left-handed ones. It didn't explain homocularity. And they stressed the experiment itself was intelligently designed, controlling the energy, trapping the products. It showed what intelligence could do, not what undirected nature could.
What about the RNA world hypothesis? The idea that RNA came before DNA and proteins.
That also faces major hurdles, they argue. Making the building blocks of RNA, ribonucleotides, under plausible prebiotic conditions is extremely difficult. Ribose sugar is unstable, linking the parts is tricky.
And getting RNA to replicate itself.
Another massive problem. Without complex protein enzymes, which supposedly didn't exist yet, getting RNA to accurately copy itself is incredibly hard. Lab experiments claiming non-enzymatic replication often use highly artificial conditions or need other molecules to help, and some key studies have had issues.
And then getting from RNA to the DNA protein world we have now.
That's a whole other layer of complexity. You need DNA, the machinery to replicate and repair it, the whole translation system with ribosomes and tRNA to the genetic code itself. Huge leaps in specified information and complexity with no demonstrated pathway.
What about other ideas like hydrothermal vents or protocells?
Vents offer chemical energy, but concentrating the right molecules, getting them to polymerize correctly, and avoiding degradation in that harsh environment are big challenges. Fundamentally, they argue, inanimate chemistry just doesn't have the goal of creating biological function. Protocells, simple membrane bubbles might form, but the problem is getting the complex, coordinated contents, genes, enzymes, inside them spontaneously. Again, experiments often require significant investigator involvement. A bag isn't life.
So the overall theme is just overwhelming improbability.
Yes. The odds of forming even one functional protein by chance are calculated to be astronomical, let alone the hundreds needed for a cell. The simplest known bacteria are already incredibly complex. We don't see fundamentally simpler life forms.
Plus the law of biogenesis.
Right. Life comes from life. We've never observed spontaneous generation. They also invoke the second law of thermodynamics, the tendency towards disorder, arguing that creating life's high degree of order requires the information and metabolic machinery that are themselves products of design. And the interdependence of DNA, RNA, and proteins creates a vicious circle that's hard to start unguided.
Okay, that covers abiogenesis. What about the origin of the universe itself, the universe from nothing ideas?
They argue these models, often associated with physicists like Lawrence Krauss or Stephen Hawking, also fall short and don't really eliminate the need for a cause or design.
How so? What's the first critique?
They question the definition of nothing. Often in these models, nothing actually means the quantum vacuum.
Which isn't really nothing.
Exactly. It's a dynamic physical state, structured, governed by the laws of quantum mechanics. So if the universe came from that, you haven't explained the origin of the vacuum or, crucially, the laws themselves. Pre-existing fine-tuned laws, Meyer argues, actually point towards design.
They also bring up basic causality again.
Yes. Ex nihilo nihil, fit from nothing, nothing comes. The intuition that something can't just pop into existence from absolute non-being remains strong. The universe, with all its order, seems to require a cause external to itself, linking back to the Kalam argument.
What about the mechanisms proposed, like inflation or the multiverse?
They argue even these speculative mechanisms often require their own fine-tuning to work. Inflation needs very specific conditions and field properties. String theory's landscape of 500 possible universes needs some explanation for why we landed in a life-friendly one, and the theory itself is incredibly complex mathematically. The fine-tuning problem often just gets pushed back a level.
And the multiverse idea itself, invoked to explain our fine-tuning via the anthropic principle.
They criticize it heavily. It's largely untestable, unobservable, unfalsifiable. More metaphysics than science, they contend. It violates Occam's razor. Is one designer simpler than infinite unobservable universes? Plus, any mechanism generating a multiverse might itself need to be exquisitely fine-tuned.
So the conclusion is that naturalistic origins theories have pretty big gaps.
That's the takeaway from this section. Whether it's the origin of life, information, and complexity, or the origin and fine-tuning of the universe itself, they argue naturalistic explanations face profound challenges, strengthening the case for considering intelligent design.
Okay, so after all that, how did they position ID itself as a scientific enterprise?
Yes, the final section argues that ID is a legitimate scientific and rational inquiry, not just religion in disguise. They frame it as using standard principles of reasoning, making testable claims, and challenging what they see as limiting philosophical assumptions in science.
How can it be scientific if it proposes an intelligent cause, which might be non-natural?
They argue it's scientific because it's based on empirical evidence, CSI, IC fine-tuning, and uses the same kind of historical reasoning scientists use in fields like archaeology or cosmology, inferring past causes from present effects.
And they claim it makes testable predictions.
They do. They point to the prediction that junk DNA would have function, which they see as being confirmed. They predict limits to evolutionary change, testable through experiments. They predict finding more CSI and IC as we study life more deeply.
And falsifiable. How could ID be proven wrong?
It would be falsified, they say, if someone could demonstrate with detailed, plausible, step-by-step functional pathways that unguided natural processes can actually generate high levels of CSI or produce irreducibly complex systems like the flagellum from simpler precursors without intelligent input.
Like the SETI analogy, if we got a complex specified signal from space.
Exactly. SETI uses specified complexity to infer intelligence. ID applies the same logic to patterns found in nature. If SETI is science, they ask, why isn't ID?
What about peer review? That's often a criticism that ID isn't published in mainstream journals.
They acknowledge the challenge, but counter that ID proponents have published relevant work in peer-reviewed journals, technical books, and conference proceedings. The Discovery Institute keeps lists. They argue peer review isn't the only measure of validity, and there might be philosophical bias hindering publication.
A key part of their argument seems to be pushing back against methodological naturalism.
Yes, that's crucial. Methodological naturalism, MN, is the rule that science should only consider natural causes. ID proponents argue MN isn't a finding of science, but a philosophical rule imposed on science.
And they think it's a blinder.
Potentially, yes. If the goal is finding the best explanation, and the evidence happens to point towards an intelligent cause, MN forces you to ignore that evidence simply because the cause isn't natural. They quote Scott Todd saying exactly that.
So what do they propose instead?
Inference to the best explanation, IBE. Consider all plausible causes, natural or intelligent, and choose the one that best explains the data. They argue this is more open to discovering reality as it is, rather than limiting explanations beforehand based on a materialistic philosophy. Science shouldn't equal materialism, they say.
Okay, but then we get back to the tricky question. Who is the designer?
Right. Critics demand specifics and raise the who designed the designer issue again. ID proponents typically draw a line here.
A line between detecting design and identifying the designer.
Exactly. Scientific ID focuses on detecting the empirical signatures of design, CSI, I say. Identifying the specific nature or identity of that designer might go beyond what purely scientific methods can determine for the physical evidence alone.
And the who designed the designer argument.
They reiterate it's often a red herring or category mistake. You don't need to know the origin story of the architect to recognize that a building was designed. And the objection assumes the designer must be complex, like its creation, whereas an ultimate cause could be fundamentally different, simple, necessary, uncaused.
But can't the type of design tell us something about the designer?
They concede that. While strict scientific ID might be agnostic on identity, the nature of the design observed cosmic fine-tuning spanning the universe. The sophisticated information in biology allows for inferences.
Such as
a designer who was incredibly intelligent, powerful, purposeful, knowledgeable about physics and biology, and likely transcendent, given the cosmic scope.
This is where Meyer's God hypothesis comes in.
Yes. Meyer argues that when you look at the totality of evidence from cosmology, beginning, fine-tuning, and biology, information complexity, the best explanation points towards a designer with attributes aligning remarkably well with a theistic God. This is presented more as a broader philosophical inference based on the science. And it's true, many leading ID proponents do personally identify the designer as God.
So, wrapping it up, they present ID as coherent, rational.
As an inference to the best explanation, they strongly distinguish it from God of the Gaps arguments.
How is it different?
God of the Gaps appeals to God because of what we don't know, a gap in naturalistic explanation. ID, they claim, is based on what we do know. We know that intelligent agents can and do produce high levels of CSI and irreducibly complex machinery. When we see those specific features in nature, inferring an intelligent cause is a positive inference based on our uniform experience, not just an appeal to ignorance. The flagellum isn't just unexplained. It has the hallmarks of known designs.
So, ID claims to be the most causally adequate explanation for these specific phenomena compared to naturalistic theories that struggle with probability or lack demonstrated mechanisms.
That's the essence of their concluding argument. It's presented as the most logical inference based on the specific type of evidence observed.
Okay, so that's a deep dive into the case for intelligent design. We've covered the main arguments, the information enigma in DNA, irreducible complexity, the universe's fine-tuning, and the philosophical connections.
Right. And we've looked at how ID proponents respond to major criticisms, particularly from Richard Dawkins, arguing against mischaracterizations and highlighting the perceived weaknesses in purely unguided evolutionary explanations.
We also examine their critique of naturalistic origin theories themselves, focusing on the hurdles for abiogenesis and cosmological models like the universe from nothing.
And finally, we saw how ID is framed as a scientific and rational program, using inference to the best explanation, making predictions, and challenging the philosophical constraints of methodological naturalism.
So here's something to leave you with, a final thought to mull over. Considering all this evidence, all these arguments about information, complexity, and fine-tuning, is it possible that a firm insistence on only naturalistic explanations might, well, be holding back a fuller understanding of where we came from?
Yeah, could the signs of design we see in the universe and in life itself actually warrant considering a broader range of possibilities, including an intelligent cause? Maybe it's worth really thinking about specified complexity, irreducible complexity, that incredible fine-tuning, and what it all might imply about our existence.
Definitely food for thought. Thanks for taking this deep dive with us.